Last time in session 3, starting 100 minutes were not recorded. So now it is being recorded verbally. You can hear the voice behind whatever I will be speaking. So now please learn from these and ask questions after you can understand the things. So let's see. Let's go into the presentation. I'll switch off my camera and we'll start in the mid somewhere. So here we are. We could not hear the voice from here. First 36 slides. So now in session 1, we learnt about the coal sampling as per Indian standards. In session 2, we learnt about the coal analysis as per Indian standards. And we also saw some advances in the coal sampling and coal analysis, which is actually to help to reduce the gap between as received coal and as fired coal, GCV. So now I'll go to show you a video which is on automatic analysis. This is by Thermo Fisher Scientific, and they have introduced a very good system which now will be able to hear and understand. Let's start the video.
Today's global coal market demands coal producers to serve customers with different quality needs and provide boilers with the correct fuel to match the load. At the same time, there are enhanced pressures to use the Earth's finite resources more efficiently. The need to produce power in high volumes while closely controlling waste, cost, and environmental impact has never been more critical to the industry. This drive towards higher production at higher efficiencies has led coal suppliers to increasingly use innovative technologies. One such unique technology is continuous elemental analysis using prompt gamma neutron activation analysis, or PGNAA. One key aspect of online elemental analyzers is that they require neutrons for their analysis technique. The simplest, most reliable, and safest source of neutrons has been the radioisotope californium-252. However, an alternate form of neutron generation can be generated by a compact type of linear accelerator that employs the use of the IC deuterium. These compact linear accelerators are called neutron generators. The Thermo Scientific CQM Flex Coal Analyzer is the next generation in the highly successful CQM product line. The CQM Flex incorporates the best of the original CQM with additional advantages. The Flex in the CQM allows for either the traditional californium-252 neutron source or the neutron generator. The neutron generator option also provides measurement of carbon and oxygen, allowing for direct calorific value measurement. Coal producers globally are facing demands such as extending mine life, production of higher quality coal, consistent delivery, and maintaining supply. In this ever-changing market, consumers are tasking suppliers to deliver on contractual obligations requirements for each consumer. The CQM Flex provides the ability to blend coals of varying qualities together to fulfill these demands and meet contractual obligations. Advantages of using real-time online analysis for coal producers include the following. Extend mine life. by mining lower quality coals while maintaining quality. Proactive stacking or storage capability. Ability to bypass CHPP. Ability to adjust gravities based on quality of input coal. Monitoring output from CHPP to increase yield. Provide ability to pre-blend coal prior to load-out coal hoppers. Reduction in rejected out-of-specification coal and penalties. Loading of trains or trucks within tight tolerance. These are just some of the advantages that coal producers using the CQM Flex have over their rivals. In today's complex coal market, operators of coal-fired power plants must be ready for types of coals that they have not utilized before. The CQM Flex provides the ultimate solution, from sorting incoming coals to blending of coal to the bunkers. Boilers' efficiency can be increased when fed a consistent coal quality. These advantages include reduced coal consumption, reduced emissions, less maintenance and derating issues. The CQM Flex provides real-time data for use by operators and quality control personnel and ensures optimal performance and reduced. Coal receipt monitoring and control provides specific advantages, such as proactive control of stockpile building based on desire, ability to reject consignments when not within quality parameters, providing flexibility to coal buyers, ability to bypass stockyards and send coal direct to bunkers, more consistent coal blends to boilers, ability to adjust loads based on real-time analysis of fuel supply, improvement in boiler efficiencies, utilizing lower quality coals while maintaining demand, blending of high and low sulfur coals, controlling carbon and sulfur dioxide emissions, monitoring of high iron and silicon coals to control fouling and slagging, fuel flexibility, allowing users to purchase wider ranges of coal. With more than 30 years of experience and a global installed base, Thermo Scientific coal analyzers have a strong track record of reliable operation and a reputation for superior quality. Contact us today to discuss how Thermo Fisher Scientific can offer a suitable.
So you saw these automatic coal analyzers. They are actually being used in mines and in the coal blending areas, and it could be very suitable for CHP, where they can decide where to dump which coal depending on this approximate GCV. Why I'm saying approximate, because the precedence tells us that there is an error of 2 to 5% plus or minus, and which plays a very important role if I do it for as fired coal. But as far as stacking the coal is concerned, either in the mine or in the blending, during the coal blending or in CHP, this could be a very handy equipment which will help all of the systems to operate properly and stack the similar GCV or similar properties coal together. Now we go into the matter. Now we discussed about the coal. Coal in raw state will have the transient moisture in that, the surface moisture. When we get this in lab, we have a separate moisture sample which we measure. So this will be coal in raw state, where we also discussed that of any wagon, the top will be having less moisture while the bottom will be having higher moisture. So the top of the coal, if sampled improperly, then will show low moisture content, the surface moisture. Now we come to the coal in air dry analytical state, where we have dried it for 24 to 48 hours in an air dry place, and we could get a weight, constant weight, and then in that coal in air dry, we may be having carbon, hydrogen, oxygen, nitrogen, sulfur, ash, and W is water, moisture again, inherent moisture. So from there, we'll again see the inherent moisture, what is there in the coal by putting in the oven and find out. Then all this comes under volatile matter when we check the volatile matter of the coal. And this is blank because we do not know whether this is methane, ethane, propane, hexane, what all are there in as volatile matter. But carbon and hydrocarbons would be there in volatile matters apart from other gases. So they will go out as soon as you burn in a temperature of 700 degrees plus. And then from decomposition of mineral matters also some volatile matter may come. Then this is finally then put into, the for the ash measurement where ash is again decomposed, organic matter will be charring and others will be, again forming a volatile matter kind. So coal in dry state will have some amount of volatile matter, not all, some amount of volatile matter minus the moisture and the mineral matter and the carbon, the organic content. And finally, what we get after burning is char and ash, which comes under mineral matter. And we'll see in the combustion calculation how does this mineral matter makes changes in the ash percentage. Same is this slide where again we are trying to tell you, coal contains many elements. First is moisture, the surface moisture, and the inherent moisture. Now this is in dry state. The inherent moisture is taken out 105 degrees centigrade, and then the organic matter, carbon, which may be combined with hydrogen also, oxygen, nitrogen, sulfur, and oxygen, then silica, alumina. This is ash content where the oxides of these things would be available. Well, we forget to, take you through the video of stone assessment in the session 2. So right now I'll take you through the stone assessment and then we'll go further about talking about the physical and chemical parameters of coal, how they affect the boiler and its design. Selection of the boiler, operation of the boiler, and its design of the boiler. Let's see a video on stone assessment and then we go further.
Let's now look into the procedure for assessment of stones. Stone assessment is done only for stones more than 250 millimeters size. Stone assessment is an important part of fuel supply agreement. According to the agreement, the purchaser shall inform the seller any incident of receipt of stones in any consignment immediately on its detection at the delivery point. The stones segregated by the purchaser at the power station end shall be assessed jointly by the representatives of the seller and the purchaser at the power station. The stones shall be loaded into trucks and weighed at the nearest weighbridge. If all the stones cannot be loaded into the trucks, then volumetric measurement can also be opted for. In the case study shown in this video, all the stones have been loaded into a single truck. Since the tier weight has already been recorded in the system, so, the truck is allowed to stand still on the nearest weighbridge and the final weight of the truck is recorded. Us now